Okay, um, this is Al Morton, and I'm a co-chair of the Benchmarking Methodology Working Group. I'm sorry I'm unable to join you in person this time, um, but I think we can have a successful meeting here with our local and remote participants, as we've done, ever since COVID locked us down. So let's see here. My co-chair is not with us, but Warren Kamari is. He's our AD advisor. Warren's remote at this meeting. Hi, Warren. And so good to see you. And we'll get right started here while folks are still filing in after lunch there. Hope you had a good lunch in Yokohama. So it's important to start out with a note well. And our special request to everybody is that we work as individuals in BMWG, and we try to be nice to each other as we work together and develop some drafts with our all of our cooperation. So let's do that. The rest of this is about IETF's policies, such as patents and code of conduct, and I encourage you to read the references if you're not familiar with that material. Okay. So here's our agenda. Everybody's able to take notes with me, and we really have a built-in tool for the note taking now. You can find it in your meeting tool or on the full Meet Echo tool. And so you're welcome to jump in and help with some notes, capture some questions, whatever it happens to be. Try to get some good cooperative notes together. So we've covered the various policies, and so we'll have the working group status. Here's our agenda. We'll talk about working group drafts, and then we'll look over some proposals for new work at various stages of progress. There's one addition, and that is that we will we'll hear more about the multiple loss ratio search at the end of the agenda tonight. So that's the plan. Just a few words on it as we get started. Okay. Any questions about the agenda? Any bashing needed? I don't see any requests for the floor. So we'll take it as is. Thank you. So here's our status. Next generation firewall benchmarking has finally been published. Big congratulations to the co-authors. How to work there. Here's the quick multiple loss ratio search update. Large rewrites in progress. As I said, we'll hear from Veratco at the end of the agenda. The Yang model has a new draft. Vladimir just sent mail to the list to describe the single change that he made. He removed a leaf that a lot of systems can implement, apparently. So that's fine. Well, that sounds like a good change. So we're going to hear about the stateful NAT gateways. We'll talk about working group last call for that. Got some questions for adoption by the working group, containerized and segment routing drafts, And of course, the proposals keep coming. And we hear about that satellite proposal again at this meeting. Some interesting results there. Okay. So the new RFC is RFC 9411. That's on the next generation firewall benchmarking. The charter's been stable, and if this is your first time at the group, you'll note that we have a supplementary BMWG page that can help you get started with the group. If you want things to happen here, especially with proposals, it's a good idea to help other people out first. That seems to be how it works the best. So you can read all about that on the supplementary page. All right, so we've updated some milestones. We've got some things coming up in August. The August one would be related to the Yang model. There's one here that we don't have any activity on now, and I'm going to recommend we delete this milestone, VNF benchmarking automation. That work it seems to have come and gone without really reaching a good point of development. So we've got other milestones to look at, and I've proposed adding a milestone for Warren's approval for the stateful NAT XY gateways. So that's on your plate to review, Warren. Thank you. And that's it. So any questions about the working group status? No? Okay. All right. So first up speaking is Gabor. Gabor, are you there?
Can you hear me?
Yes. Yes, I can. Would you like to run your own slides?
If possible, yes. Maybe it's easier if I can share my own slides. How can I do it?
Do you have the
screen share?
Yeah, you wanna share preloaded slides?
Yes, it depends on you. I've got the slides on my laptop, or you can share my preloaded slides, whichever you prefer.
I think there's a button you have to press to share the preloaded ones, which will work best. See if you can find the share preloaded slides button.
I just see yet the okay, wait a minute, presentation view. Yes, it's just I see the MetaQ icon. I cannot see yet the slides.
Okay, let me get.
Something's happening. Yes, a new deck is being shared. Yes, I can see now the slides. I hope that also others can see it.
Yeah.
So our methodology.
But you can't control them, right?
I can control. I'm not sure. How could I? How? I think I cannot control them.
Yeah, that's what I was trying to get you to do. There's a button here that says, "Oh wait, I can grant preloaded slides to you."
Yes,
okay.
Something is happening. The
Okay.
numbers appeared. Yes, okay. Now I can control them. Very good, very good. It's very easy to do it for myself. Thank you very much.
Thank you. We figured it out. Good job, Gabor. Please go ahead.
Okay, so I'm very happy that I can share the current status of our draft. So as many of you know, it is about benchmarking methodology for stateful NAT 6.4 and 4.4 gateways. And of course, in a way that we use the RFC 4814 pseudorandom port numbers. So the first slide is just a kind of summary of the methodology. I managed to jump to the second one. Okay, once again. Okay. So the purpose of our draft is to make it possible to reuse the well-established benchmarking procedures like throughput, latency, frame loss rate that were defined in RFC 2544 and later refined in RFC about benchmarking methodology for IP version 6 extension technologies. So first of all, we need to enable them to work with IP version 6 extension technologies, especially with the stateful ones, because if you just imagine that, for example, throughput uses bidirectional traffic, and if you want to conform RFC 4814 with several random port numbers, you not just invent random port numbers because they will not go through the stateful NAT64 or 44 gateway, especially in the download direction. So we have to do something to make it work. And we also have some stateful specific benchmarking procedures to measure stateful specific measures, characteristics, for example, maximum connection establishment rate, connection tear down rate, and connection tracking table capacity. So our methodology propose to solve these issues. And here the short progress of our draft. So in summer, 2 IETF meetings ago, our draft was adopted as a working group item. And since then, we added some methods for scalability measurements and reporting format. And our current version contains, besides these things, the usage of multiple IP addresses. So let me just give you a quick reminder about how it works and the main ideas of our draft. So the first and most important thing is the test setup. On this slide, you can see the usual two devices, the tester and the device under test. And as the device under test is a stateful NAT64 gateway, of course, it could be a stateful NAT44 gateway too, but we use the example of stateful NAT64. It is not possible to just send traffic through the gateway in the right to left direction. The connections should be initiated in the left to right direction. This is why the left side port of the tester is called initiator. So it can send IP version 6 packets through the device under test. And up to a measure, it can invent any port number combinations. And the device under test, the stateful NAT64 gateway, just translates them to IP version 4 packets, and it registers the connection information into the connection tracking table. And then the IP version 4 packets will arrive to the right side of the tester, which is called responder. This port just extracts the information, the 4 tuple, I mean, source and destination IP addresses and source and destination port numbers from the IP version 4 test frames and stores them in the test table. And later on, it will be able to use proper IP address port number combinations from the state table to be able to send valid test frames through the device under test, which are belonging to an existing connection. So I already mentioned the word later. So I mean that we have two test phases. The preliminary test phase serves two purposes. As I said before, the connection tracking table of the device under test is filled, and also the state table of the responder is filled with valid 4 tuples. And it is a precondition for the real test phase. But this preliminary phase can be used without the real test phase to measure the maximum connection establishment rate. And in the real test phase, we can perform the classic measurement procedures like throughput, frame loss rate, latency, packet variation, etc. But it must be preceded with a preliminary phase, which prepares the system to be able to perform these benchmarking procedures, as I said. So to have repeatable measurements, we can achieve two extreme situations that can be easily done. The first one is when all test frames create a new connection, it is ideal for the maximum connection establishment rate measurement, that it happens in the primary test phase. And the second situation happens in the real test phase. It is when test frames never create a new connection, and of course never terminate a connection. This is either ideal for the classic test, the throughput, latency, frame loss rate, etc. And we can achieve them in a way that we use large enough and empty connection training table for each test. So we delete the connection training table after each test. And we use pseudo-number enumeration of all possible port number combinations in the primary phase. For this reason, no new combination may occur in the real test phase. And of course, we have to use a properly high timeout value, which is higher than the length of the preliminary phase, the gap between the two phases, and the length of the real test phase. So this methodology seems to work well. And last autumn, I was in Japan and dealt with testing and validating the methodology. So I tested it with 3 different stateful IETF116-BMWG-20230328-0400 implementations. It was Joule and Taiga, which is a stateless net 464, but combined with IP tables together, it gave a stateful NAT64, and also used OpenBSD PF, which is another stateful NAT64 implementation. And I found that the solution primarily works well. However, our approach was that we use only a single source and destination IP address pair, and we use multiple port numbers. And of course, we have to limit the port number combinations, otherwise they would exhaust the capacity of the connection training table. And it worked well with Linux. And even if we used multi-core computers, it worked well because we could set the register size scaling implementation. So there's an add tool command with which you can set the proper RSS, and the interrupts are distributed among the CPU cores, and everything works well. However, it turned out that with OpenBSD there was some problem, because even OpenBSD, with some cards RSS would work, but there's no way to tune the hash function. So it only takes into consideration the IP addresses and not the port numbers. And this way it was not very good test with OpenBSD. So it came the idea that we also need to use multiple IP addresses. And how to generate multiple IP version 4 addresses. Of course, we have plenty of version 6 addresses, but we have some scarce number of version 4 addresses. So when router testing is done, the original RFC 2544 says that first we should use a single IP address pair, and then we should use 256 different destination networks. For this reason, we have some address ranges. So let's say on the left side of the tester, we use 198.18.00 per 24, and on the right side, we can use 198.19.00 per 24. And as we do not do router testing, we do not need multiple networks, so we can use these bits from, let's say, 16 to 30 to 23 to generate high number of IP addresses. And it would be better because the nature of the traffic would reflect better the internet traffic that would hit the stateful NAT/XY gateway if it is applied to forward internet traffic. So this is our proposal, that on the right side of the figure, you can see that we can add multiple IP version 4 addresses. However, we have to take care that if you use a stateful entity 4.4 or 6.4 gateway, of course, it must use multiple public IP version 4 addresses. So we kept a range from 0 to 127 for the public IP version 4 address of the gateway, and the other half of the range could be used as destination addresses when we send the traffic from left to right. And on the left side, it's not a problem because we can use any private IP address range, and it is enough to have a single IP for address for the device under test. So we got a large enough range for multiple source addresses. And of course, the same works with IP version 6. So you can see that we can use the same address IP version 4 address management for the right side, and the left side we have plenty of version 6 addresses. So I think we can do it, but we haven't done it yet. So it is just an idea how we can use multiple IP addresses. Our tester has not yet implemented it. So we can perform tests only with a single IP address pair yet, and with multiple port numbers, but it has to be implemented. And I plan to do so, but first I would like to check with you if you find this method good and it should be implemented really. And any comments are welcome. So I think now the method is more or less designed, and I'd like to get feedback from the community if it works well or we should do something else. Yes, thank you.
Thanks, Gabor. So we've all just sat through a good reminder and summary of this and your proposal. Any comments from folks in the room or on the Meet Echo session? Okay. So it doesn't seem like we're going to get feedback at this point in time, Gabor. But will you be? Do you think you will implement this anyway and give it a try?
Sorry, I didn't understand what you said.
Do you think you will implement this proposal anyway and give it a try?
Yes, of course. If no opposition, then I plan to implement and see how it works. So only the multiple IP addresses should be implemented, and then we can see if it's good or not.
All right. Well, why don't we do this then? Why don't we give you a chance to do that, this implementation of the new proposal for the draft, and then when you got some results or an updated text, then let's take this topic up for more discussion, and at that point, possibly start the working group last call after that. Does that sound reasonable?
Yes, thank you. Thank you.
Okay. I'm just capturing a few notes here. Good. Okay. All right. So any other general questions about the draft? Has anybody in the room read it? Anybody on the Meet Takeoff session? I know a lot of people have read this, Gabor. They're almost all the names I'm sure are in your acknowledgments. We've seen pretty good review of this over the last several years. Okay. All right. So it doesn't seem to be attracting much comment in the live session here, which is a little disappointing. I usually look to people, to come ready with having read the draft and comments. So let's leave that as a strong suggestion for next time. Okay. Okay, Kapoor. Well, thanks again for preparing your proposal and your talk.
Thank you.
All right. So now we're going to change to benchmarking considerations for performance in containerized infrastructure. And I think Min Nuk Tran is going to give this talk. Is that right?
Yes. Can you hear me?
Yes, I can. So since you're up front, I'll control the slides for you here.
Yeah, thank you. So hello everyone, I'm Min Ngọc Trân, and on behalf of my co-authors, we present the update of our draft consideration for benchmarking network performance in containerized infrastructure. Next slide, please. So the first thing is that between our previous versions and this current version, we have the review from the Viper of the Linux Foundation for this draft. So we would like to thank Anne and Frita for reviewing our draft before the meeting. So quick introduction about the draft is that we provide additional consideration for containerized infrastructure benchmarking compared with previous benchmarking methodology for common NFV infrastructures. The consideration that we want to address is the different container networking models based on different packet acceleration techniques and different resource configuration setting that might make performance impacts on network performance. Next slide, please. So the update summaries between the previous one and this one is that after we discussing our draft with the Viper project, and we removed the two section and we enhance the demonstration of the eBPF acceleration model, and then we add a new section for resource configuration, that's the CPU cores and memory allocation. Next slide, please. So the reason about the remove section, the deployment scenarios. So this section is about container. There are two kind of scenarios that port can be deployed. It can be deployed on the bare metal, or it can be deployed on the virtual machine. However, after Viper review our draft, we all agree that both us and Viper had that similar scenario, and the performance difference is negligible. So it's better to not include this one inside the consideration. And about the configuration parameters, that we agree that it should be placed in the resource configuration consideration section. And this is redundant for now. Next slide, please. The next update is an enhanced section of the eBPF acceleration model. So in previous version of the draft, we only have one general architecture figure to show the eBPF acceleration model. So Viper suggests that we need to split into three categories. So the first one is a non-AF SDP. So this includes the CNI, the mainstream CNI that like Cilium or Calico. So with the two, the EPF is placed on the NIC drivers inside the TC hook near the NIC driver for the ingress side, and on the egress side is placed in the TC hook at the virtual interface of the port. The second one is using the AF HDP supported CNI or for Kubernetes. For this kind of model, then it works similar with the SROV. Then which means that the packet can be deployed directly from the network device or from the sub-network function. And finally, the AFSTP support user space vSwitch. So with it one, in order to point the packet from the NIC driver, then especially from the AFSTP socket, then a user space vSwitch need to be used with the corresponding AFSTP point mode driver. Next slide, please.
Yeah, hang on. The next time you guys want to show this slide, I think you're going to have to redraw it so that it's actually visible in slide form. I know this is the ASCII art right from your draft, but this is almost impossible to read here in the Meteco window. So please consider that for the future. Thanks.
Yeah, okay, we notice that. The third one is CPU cost and memory allocation. That is a new resource configuration that need to be considered. So different CPU cost and memory allocation to POS and vSwitch point mode driver might impact the container network performance. So both our hackathon benchmarking test and Viper had investigated the impact of this setting, and Viper also published their results. A summary that increasing the POS CPU can significantly increase the throughput. Different RAM allocation cost different and inconsistent throughput, and increasing the CPU core allocation to VP vSwitch cost better latency, but not with the OVS DVDK. Next slide, please. So this is a little bit of update from our hackathon results. So in this hackathon 116, we perform some verification tests of all the considerations that we have placed inside our draft. The first thing is different performance caused by different networking models. So in our verification, we can confirm that the SROV had the best result, nearly the light rate, and followed by VP and OVS DVDK, and also OVS with AF's XDP validation. Then we also see that combined the SROV and VP will perform better than using VP only in a switch chain scenario, with increasing the number of POP only impact the performance for smaller frame packet. Next slide, please. The second result is for the CPU and memory allocation impact. So previously, Viper had tested this one, and they observed that different CPU and memory allocation will cause different performance. But the test was based on the older versions of the software, OVS and DVDK. And in the hackathon 116, we performed similar tests, but with a recent version of the software. And we cannot see and didn't observe the impact of the CPU and memory allocation there. So we need to inform Viper about that and discuss about this later. Next slide, please. Now, this is the same. Here's the memory allocation as well. Next slide, please. So this is a result that show the performance also different when we have different alignment for port, vSwitch, and NIC in different NUMA. So we can see that when we aligning the port, vSwitch, and NIC in the same NUMA, we have the highest performance. Next slide, please. So in conclusion, that after getting review from the Viper, we would like to ask for adoption of the draft as a working group draft. We also got several interest from people from the working group. Recently, we got the Gabo as he has sent some interest to us, and our draft also mentioned by the BPF in yesterday meeting, and we also want to welcome any feedback and reviews. Thank you.
Okay, thank you. So, any questions about the draft and the results that have been presented from these were from mostly from the hackathon last year, right?
Yes. Yes.
Okay. All right, Kapor, I see your request. Please go ahead.
do you have some new results this year in current hackathon? Did you have some new tests?
The new results is about the CPU and memory allocation impact as we have shown in previous one. I have updated a slide with the latest results, and we see that with the newer versions of the software, then we didn't see the impact of the CPU and memory allocation. And about the others, then the result is different with when we test about different networking model, but the similar pattern can be observed. Is still the SRV the best, and we follow by VVP and OVS.
Okay, thank you.
Oh yeah, here it is. The hackathon 116 did not observe the impact of CPU and memory to the pod. Okay. All right. So I know we did get some commentary this time, but I noticed that at our last meeting, Masiek and Feratko, the MLR search draft authors, signed up to review this work, and I'm very interested in their review before we take this draft up for adoption. So I know Feratko is on the well, at least he is still on the session. Do we think we can get these reviews in a timely fashion? Feratko, maybe a combined review from the two of you.
Well, to be honest, we are quite busy right now, so timely may not be very quick. But yeah, this is one of the areas we will be looking at. So the review will be coming, just not as timely as we would like.
Okay. All right. Well then, why don't we do this? When you guys think you can review, let me know, and then we'll start an adoption call, and the review can be part of that adoption call. Does that make sense to everybody?
Yes.
All right. So the ball's in your court to let us know. And like I said, maybe it could be a good combined review to handle this, okay?
Yes.
Would anybody else like to review the draft? Gabor, okay.
Yes, I also would like to review. Please record it. I promise to review it.
Very good. Very good. Okay. All right. So I'm recording an action to wait for the review notifications. And then start the firm request or working group adoption. And so Franco and Masiak have that to let us know when they can do this. And of course, Gabor, you can review anytime. Okay. All right. Thanks, Minnak Tran, for your presentation today.
Okay, thank you.
All right. I'm changing text now to benchmarking for segment routing v6. And Edward, I think you're going to do the presentation here, right?
Okay. Okay. Probably I could speak, right?
Yes, I can hear you.
Next slide, please.
Well, it looks like, I got these a little out of order, but that's okay. Let's just go with
No
this
problem.
one.
No problem. Yeah, of course, no
Yeah,
problem.
yeah.
Yeah,
Sorry
I
about
could be
that.
first. No problem. Next slide, please.
Okay.
We present this particular draft third time. The primary goal, of course, is benchmarking for SRv6. SRv6 is more or less new and hot technology. It's effectively, from methodology point of view, it's a combination of IPv6 and MPLS, because it serves the purpose of MPLS, but in reality it's IPv6. For that reason, it's a merge of a few things which we before. Of course, the basement is RFC 2544, but additionally it's MPLS RFC, which is in the basement. Additionally, it's IPv6 RFC, which is in the basement. And we have discussed it already many times. Next slide, please. Okay. What is principally different for SRv6? That SRv6 has special header, and this special header could be attached and could be cut at a particular point of network, and because of this, potentially 4 cases are possible. Right now we have 4 cases in the draft after last correction. The 4 cases then transit node do nothing about header because it's not aware about header, because it's for transit node it could be just a IPv6 packet. Then it's at encapsulation happens, then this additional header, SRH header, is added, and could be decapsulation could be 2 choices. One choice, it's penultimate pop hopping, then it's decapsulated 1 hop before the final hop, and the decapsulation could be on the final hop. And of course, inside header could be a little bit different. Encapsulation type could be different. Flavor type could be different, and for that reason, it has more or less big number of combinations, which is potentially possible for SRv6, which is right now everything in the draft. Next slide, please. This particular slide is historical. We have shown it without changes from last IETF. For that reason, I will not talk too much about it. It was a big review which has been done by Gabor and Boris, and after this we have changed a lot in the draft. Next slide, please. Okay, yeah, this is new because okay, Gabor has read again our draft and found something else. This time much smaller, but anyway, has found something. But this time we have a review from Bruno, and Bruno has found something really fundamental, some really big things, which he has found effectively elephant in the room, and we have to change considerably the draft. And thanks for Bruno, who has joined this particular activity. Now we have added flavors. We have added fourth case when decapsulation in transit, and a little bit expand the stack size because in real in real deployment, it looks like we need more options. We need more bigger label stack, more labels in the stack. It's not called labels here; it's called seed. But okay, like in PLS, it's labels. Okay, next slide, please. By comments and by size of comments and by essence of comments, we see that the draft is more or less stable. Of course, we still need to think about it all together and to find what to improve next. And of course, especially we need to test it in real deployment, in real something, in production, in real deployment, to be considered seriously, because without this, of course, it could not be RFC without proper test. But we're asking for adoption because we believe it's already stable draft, and we believe that if would be adoption, would be more attention, and would be more attention not just for review. For review, we already have more or less good coverage, but what we need right now for attention, we need to real test. We need to make it interested for some big carriers to really test it, and for this, adoption could help a lot. Of course, review maybe improve too, but especially for real test, we're asking for adoption. We believe it's stable. That's it from my side.
Okay, good. Thank you, Edward, and thanks for volunteering to review the container.
Previous one, yeah, previous one, yeah.
I just saw your comment there. So first off, you've done a good job presenting this. Are there any comments from folks in the room? Wow, very quiet microphones. Oh, please go ahead.
Yeah, because I cannot reserve here. I actually just ask questions here.
Okay, no
Louis
problem.
Chen from Juniper. I think you know that there's micro seeds, right? Compression seeds, right?
No. Because yeah, good question. Yeah, sorry, I will answer because microseed is not a standard yet. It's not finalized yet. It's still draft, and for that reason, and because this particular draft is already very big, for that reason we had decided to put it out of the scope. We will need additional maybe version or maybe additional document. Microseed is not in the scope.
Okay. No
if you believe it's wrong, okay, it's discussable. If you believe we should expand the draft even more, it's possible to do. We're not strictly against this, but just we see the draft is already very big, and if we will adhere microseed, it would be even bigger. And yeah, up to you. If you like, we could improve. We could adhere microseed. It's discussable.
Yeah. Okay.
I'm missing that word, micro. What is it?
Microseed, small seed, microseed. Yeah.
It's a compression method.
Yeah.
Yeah.
Yeah,
it's a special version of seed which is still not a standard. It's still a draft. It's Spring Working Group draft.
Okay, so everybody said that together, and so I'm going to put in the chat what I heard. Microseed. SID.
Yeah.
SID.
Yeah. SID. Yeah.
Good. Thanks, Warren. All right, so we're sort of agreeing to leave that out of scope. Good. Thanks for the question. So then, can we get some? If we put this up for a working group adoption, can we get some volunteers who will guarantee they'll review it during the, let's say, 4 weeks adoption period? Well, apparently not. I'm really looking for some help here from the working group. We've got to get more active reading these drafts, or we're just not going to be able to take up the work. And that's not good because the authors have put a lot of work into it. And Edward has described the benefits of work group adoption that'll actually help the work. Where carriers will see this and maybe help out with the testing. So I'll ask that again. Any volunteers to review this draft? Okay. Well, this is going to be a topic we're going to have to take to the list, I guess. If we can get some volunteer reviewers, then we can have an adoption call. But I'm very reluctant to start an adoption when no single person will put up their hand and say they'll do a review. I hope you understand, Edward.
Yeah.
All right. So we'll take the topic of adoption and volunteer reviewers. To the list and try to get some volunteers. Okay. All right. Thanks. Thanks, Edward. So now we'll go to the MPLS segment routing. Sorry to get things a little out of order there, but I think we're back on track here now. So hi, Paulo.
Hello, Al. So, shall I start?
Yes, please do.
Okay, so Paolo Volpato, away. This is basically the second draft that the same group of authors have developed, having in mind segment routing, this time applied to MPLS network, so the existing MPLS data plane. Next slide, please. So just have a quick recap at what we did. So the reason for having this draft. Edward introduced some, let's say, concepts which are applicable to the second draft. So I'm sorry, I will repeat something. So basically, at the moment, there is no existing method to, let's say, benchmark the segment routing packet forwarding capabilities of a network device. So that's the reason why we build this second draft. And I take the chance for introducing one important topic, I would say, at least for us. Sometimes we receive the question, are we speaking of the same draft, just, in two flavors, just to address the benchmarking of the SAR capabilities on the two data planes? As you see, no, we are speaking of two different and separated drafts, because it is true that the foundational technology, so the architecture of segment routing, is common to both, but then we need to apply segment routing to the differences provided by the two data planes, IPv6, as explained by Edward with the previous draft, and MPLS for the current draft. And speaking of segment routing applied to MPLS, you see, I'm not going to read the entire slide, but the key characteristics are that we have a head-end node that steers the traffic according to a policy, to a SAR policy, which is a sequence of segment identifier, or SID, we keep the state only at the end node, and the state is not propagated in the network along the path. We just have per flow steering based on the policy which is defined by the end node. As I said, we built on this draft having in mind the benchmarking RFCs. You see the list here, and specifically 5695, which is the RFC defining how to benchmark an MPLS capable network device. As I said, we have to consider two data planes, and this specific draft is about SR over MPLS. So next slide, please. And since we speak of MPLS, we all know that there are three key operations on the MPLS data plane. So we need to define the policy, the sequence of seeds, as a sequence of labels which are inserted in front of the packet. And the forwarding functions which are available are the three which are listed in this slide. The push, corresponding to the traditional MPLS label push. So we push a sequence of seeds in front of the incoming packet before it is sent out. There is the next operation corresponding to the MPLS label pop. So basically, we remove the topmost label and we see which is the next operation to be applied to the packet, and then continue, which is the same operation as the traditional MPLS label swap. So basically, we associate an incoming label with an outgoing interface, and then the packet is forwarding according to the operation. So the reason for expanding what RFC 5695 did, because we need to benchmark the capabilities using a seed list which is longer than one. We need more than one segment identifiers. Clearly, we have also to, let's say, modify the reporting format. We need to, based on the comments we have received on the list, to enable at least one dynamic routing protocol to perform the test. And clearly, since we are speaking of benchmarking, we need to repeat let's say, the test for every single operation. Next slide, please. As Edward did for the other draft, we have also put here a very short history of this second draft on SR MPLS. Probably you remember we submitted the two drafts around a year ago, so it was March 2022. We presented version 01 at the IETF113. We received several comments from the chairs, so we incorporated them into version 02, which was discussed at IETF114. You see all the, let's say, the comments that we addressed. I would say that I jumped to version 3 and 4 because those were developed and eventually submitted for the past IETF. We received comments from Gabor, from Boris, from the list, and that was very important to, let's say, to make the draft stable, as pointed out by also by Edward before for the SR V6 draft. Then we received further feedback. And again, I take the chance of explaining what we are currently doing with the two drafts. So whenever we received a comment which is applicable to either of those, so to one of the two drafts, the group of authors cross-check also the second one to see if that comment is also applicable to the other, in a way that we are trying to, let's say, keep the two drafts synchronized. So there is a sort of internal revision that we do whenever we receive a comment. And specifically, as Edward mentioned before, we need to thank Gabor and Bruno, who provided further comments. So that's the reason why we developed version 5, which then turned into version 6 because we also fixed some editorial things in the 2 drafts. So basically, we uploaded version 06, which is the version we are discussing right now. Next slide, please.
Yeah. Before we go on, Paulo, I wonder if you remember how you're using this reference to the ETSI TST007. How is that used in this draft?
So basically, we introduced that for, if I remember correctly, it was to address one of the comments received from you, Al, and I think it was about the benchmarking of virtualized, let me call it entities.
All right, so then I think the number's wrong. It should be test 009.
Okay, good point.
So yeah, so please check that in the draft. It makes a big difference. Test 007 and 09 are not, they have very little in common. I think 09 is the one you want.
Okay, so good point, thanks. We'll fix it.
All right, thank you.
Good. So conclusions are quite similar to the previous draft. As I said, the 2 drafts are kept in sync. So we believe that the text for both of them is quite stable, at least for considering the adoption from the working group. The same motivations apply also here. So we believe that probably adopting also this second draft brings more attention to the work that we are doing. And so we're proposing to the working group to consider adoption. And clearly, we are also open not only to receive further comments and see if there are further topics to be included, but also in case there are people interested to join us, we are more than free to do so. And I would thank you for the attention.
Good. Thank you, Paulo. So I see we have someone at the mic. Please state your name very clearly. I'm trying to capture it here.
Yeah, same one. Louis Chen from Juniper Network.
Thank you,
So,
Louis.
question. Yeah, thank you. The question actually, I believe it's good to test the label depth. Longer list is good, but from performance perspective, there's no difference because each hop only perform on the top labels. Yeah, right. Or it may be only top 2, right? Maximum. So I don't think there's any kind of difference. Okay, unless you push the first one to have inside a very large label depth, then you see the difference of performance. Otherwise, I think the same, right? This is the first comment. Yeah. Second one is if you want to test it, then the label, that means the network, there's similarly bigger networks. That means you have more labels that will better test result. That means you have 1,000, 10,000, the result was different. Some of the labels, right? I mean, the prefix it, all these things, right, were different, right? And then the third one actually is testing you might consider because in some implementations, they can take action on the course, QoS, on the labels. That means based on the label, different labels, they will do policing or do some kind of shaping. So that sort of thing can be tested as well as a scalability as well. I just see whether that could be included in your considerations.
Well, thanks for the comments and questions, solicitations, I would say. Sure. So the first one is why considering a a long list of seats. Actually, the idea is that even if we are not considering right now, for example, the support of the services carried by the MPLS label stack, for example, VPN could be further introduced in the draft. So that's why we are considering from scratch having at least 2 seats, for example, 2 labels, let's say. For the scalability consideration, good point. I would say we can consider that. So let's stay, let's say, in contact just to, you know, further develop this possibility. It's a good point. The third one, I'm missing your third comment.
A cost portion, because in some kind of implementation, they were based on the top labels to do some QoS, maybe policing or shaping. Then the scalability, that one also is kind of considerations.
I think we touched briefly that possibility. I think it's a good point. So we can, again, we can expand the text just, you know, to take into account. Thanks.
Good comments. Thank you, Louis. And good responses, Paulo. So, do we have anybody else in the room who's read this draft? And since you're asking for adoption, will anybody volunteer to read this draft during a 4-week period for to consider the working group adoption? Please let me know either online or in the room at the mic. Well, again, I guess we'll have to ask for some review volunteers on the list. I'm sorry about that, but it seems like we've basically got an audience that hasn't fully engaged with our work. I'm sorry. So the mailing list will reach a lot more people, and let's hope for the best. Okay, Paulo?
Yes, sure. Thank you.
All right. Okay. So the next talk is on the considerations for benchmarking network performance in integrated space and terrestrial networks. And Ji Sang, you're present.
Yeah. Okay, can you hear me, Al?
Yes.
Okay, let's start now.
I can pass. I've passed control of the slides to you.
Okay, I got the control. Okay, thank you. Okay, so let's go ahead. So we are very happy to be here to give our considerations for benchmarking network performance in integrated space and terrestrial networks. And the work is from the Tsinghua University and the Zhongguancun Laboratory. Okay, we are changing the slide. Okay, let's first have a quick review on the motivation, why we need a new methodology. On IETF 112, we have presented our problems and requirements for benchmarking methodology for the integrated and space and terrestrial networks, which that is ISTN. Recently, the whole networking community found that we are on the highway towards ISTN, which can network the whole globe through LEO or low Earth orbit mega constellations and terrestrial networks. And most importantly, it is a totally new network because they are newly featured by global level high dynamicity and unexplored uncertainty like the outer space environments. So we definitely need new network designs and which should be comprehensively and systematically benchmarked in lab before we launch it into the space. So we also give our requirements for the benchmarking methodology. It should be with constellation and network realism, and should be flexible on the mega constellation scale, and should provide realistic data and test cases. And most important, last but not least, it should be of low cost and easy to use. So we also found that we didn't find one existing methodology which could satisfy all the requirements. And secondly, after 1 year, about 1 year, with the feedback from the BMWG community, we give our basic preliminary considerations for the new methodology on IETF 115. So we ask what is the expected benchmarking methodology for ISTN. It should be qualified for all the requirements we mentioned and should also be in lab, as the BMWG charter describes. So we give our preliminary consideration. It should be a data-driven and emulation-based benchmarking approach, which is consisted of the following 3 stages. First is a community-driven data collection stage. And then we, based on the real data, we set up an isolated test environment via virtual machine or container-based emulation, which could mimic the LEO behaviors, that is, the dynamics of the LEO satellites. And last, we could specify some specific DUT or SUT, like some routing protocols, transport protocols, or routers, and we then run some specific test cases. Okay, so this is a basic idea we gave in the last meetings. So this time, we want to so this time what we want to do is to update towards a more concrete benchmarking methodology. So this is the content of the following slides, what we are going to present today. We are going to concretize the first stage, which is the community-driven data collection stage. And we are going to give some ideas on how to set up the parameters for the benchmarking environment for ISTN. And the data will be from the regulatory data, the live data, and also the crowdsourcing data. After that, we will also showcase the parameter settings by giving the network performance under different environmental setups. And then we will describe our future work, which will be cooperation with academia, with industrial and IETF community. Then we gave our the difference from our last draft 00. So the difference appears as the fifth chapter. We remained the contents from the last draft as the terminology, and we added some new contents, which is how to set up these parameters. And this is what we want to present today. The first we want to consider is how to set up the constellation orbital parameters. We got 2 data sources. One is regulatory data. So we believe that the regulatory data-driven orbital parameters should be tested in the benchmarking process. The orbital parameters of all the constellations should be reviewed and made public by the regulatory agencies like FCC or ITU. So these parameters made public should be followed by the operators in principle, and thus these parameters represent the ideal situation of the constellations. And the second data source is the live data-driven orbital parameters. It is recommended because it is based on the live constellation GP data or general permutations data, orbital data from the sidetrack.org. Because it was produced by fitting some real observations like radar observations or optical observations from US Space Surveillance Network or SSN, and it is provided continuously, so it could represent the live situation of the satellite constellations. For regulatory data, we provide a table of the state-of-the-art constellations. They are divided into two kinds. The first is polar orbit, and then is inclined orbit. We believe they both should be tested, unless the protocol like the DUT or SUT is designed with orbital preferences, and this preference should be stated in the report. And for the live data-driven orbital parameters, we also have two kinds. They are GP data and sub-GP data on the website, which we can get. And among them, the sub-GP data is recommended because it was supplemental and derived directly from the owner or operator supplied orbital data, which could provide reduced observation latency and improved accuracy. The max age of the GP or sub-GP data should be less than 1 day and must be less than 5 days. However, comparing to the regulatory data, the live data, although it's more accurate in terms of the per satellite position, but it requires extra orbital determination process, which implies the inter-satellite relations to support our following network experiments. So if one day the orbital determination process could be standardized, the live data-driven orbital parameters should be used to benchmark. And the next is to set up how the ground stations are distributed around the world. A recommended data source is crowdsourcing data, which is often refined by the fans community based on the regulatory data, which means that there are real satellite users from the world to observe the stations in person and provided the informations together. And like the left figure shows the Starlink ground stations in EU area, and the different marks with different colors in this page is featuring the details from the community, like it representing the different number of antennas at different ground stations. And we also have other optional open data from the Amazon AWS or AZR Orbital or other open ground station services are provided to the public. The right figure shows the Amazon AWS ground stations around the world. And the third parameters to set up is how the nodes are connected with each other. We also recommend the crowdsourcing data. For example, the right figure shows the ground station connectivity of the Starlink ground stations around the world, and it was explored with trace route from the fans community with real satellites. And except this, the strategy-based parameter setup is recommended because we don't have real data in this part. For example, for the inter-satellite connectivity, we recommend a plus grid where the satellites are connected with the 4 neighbors, like 2 neighbors in inner orbit and 2 neighbors in neighbor orbits, and they will form a massive grid across the constellation. And other optional strategies are to connect only inner orbit satellites or a more complicated motif strategy. And for the ground satellite connectivity, we recommend the nearest ground station with antenna quota, which means every satellite will be connected to the nearest ground station. With every ground station will have antenna quota, which is and 8 is recommended here for the antenna quota. And last, it is a more traditional parameter, the network link. At this stage, we recommend the strategy-based network link setup. For example, the propagation latency of the links, like ground station to satellite link or inter-satellite link, could be derived from the distance and light speed. And for the capacity of the ground satellite links, it could be set from between 1 to 5 Gbps, and specific value may be derived from the frequency band informations from the regulatory data. And for the capacity of the inter-satellite link, it could be set to 5 to 20 Gbps from the commercial informations we've got. However, we also have some crowdsourcing data related to network link, like the measurement data on the path latency and bandwidth from the satellite users, but we didn't find a quite good way to use them. We think they may help on determining the coefficient when calculating the latency from distance and the light speeds in the future. So this is a showcase which shows the latencies under different constellations with the regularly data-driven. And they are the statistics of the latency under OSPF between different ground stations around the world. And with the environment, we could benchmark other routing protocols and compare between them. And with the future work, we are going to progress with the four sides. The first is with our self-owned devices. We will continue to collect more real data with the big devices like satellite dishes and high-end servers, which are running the satellite emulations. And secondly, we will make progress with academia. And our latest work on ISTN emulator, StereoNet, will be presented soon on NSDI 23rd, and you may join us there if you are interested. And we are also continuously working closely with our industrial cooperation partner, like the China Mobile and China Telecom. They are the real satellite communication operators, and one of which has more than hundreds of thousands of real users. We are working closely with them on the network ISTN design and benchmarking. And last but not least, we have been working with our IETF community who are sitting there And we also wish to see you in person at IETF117 and in the future. And here we request for comments on what we present here today. And in the future, we will work toward a more concrete benchmarking methodology for like routing or transport or even security functions in ISTM. For example, the specific parameters include the definition and the measurement methodology for specific metrics for different protocol, the distribution of the end users, the duration of the benchmarking, or some other dedicated setup of the DUT and SUT in ISTM. So that's all we want to present today, and we thank you for your listening, and comments and questions are welcome. Thank you.
Very good. Thank you. Are there any questions in the room or folks on MeetEcho? Okay. Could you go back to slide 12?
12. Okay.
Yeah.
Is this right?
So you're talking about latencies here, but there's statistics of latency, parentheses, OSPF, between ground stations in the world. What exactly are you measuring here?
Pardon?
What are you using to measure the latency?
Oh, we measure the latency with ping command, right?
With ping. Okay.
Yeah.
So why does this say OSPF?
Because OSPF determines the latencies between the different end, and ping is just the way to measure the latency. Because we focus on the protocol or the strategy. Yeah.
So you're saying OSPF determines the routing, but ping is actually being used to make the measurements. Is that correct?
Yes, yes.
Okay. So let's so you got CDFs here for the latencies of these different satellite services, and it looks like Telsat is usually has the longest delays.
Yeah, because we believe it has the least number of satellites, and which makes the latency somehow is larger than others.
Okay. And of course these are round trip latency, right?
Yeah, round trip.
Yeah. Well, it's fairly easy to see that there's a real benefit in this this low Earth orbit satellite systems. These would all be in the 200 to 500 millisecond range if these were over geosynchronous satellites. So there's some clear benefits here.
Yes, that's why the world is pursuing for LEO constellations now, right?
Okay.
Okay, we see someone on the line, right?
Yes. Please go ahead, Paolo.
Yes, thank you. Just same slide. It's a curiosity of mine. I guess that the latency measurement is done considering IPv4 connectivity, right? So when you do the ping, it's an IPv4 address that actually you test using the ping command. Yeah, exactly. The curiosity is if you are considering also IPv6 connectivity, if you test it, or maybe you plan to just to see if IPv6 is supported.
Yes. We actually use IPv4 here in this test.
Okay, good. Thank you. Well, just suggestion. I know maybe it's out of your analysis, but since there are several working groups here discussing how to improve the use of IPv6, that could be something you may consider for the, let's say, the evolution of your activity. Thank you.
Okay, thank you. We will consider that.
Okay. Any other comments? All right. Well, it looks as though you're making some progress, so that's good. And I guess we look forward to hearing more about a methodology that we can really put under our scope here. Hopefully at the next meeting in San Francisco.
Okay. By the way, I wonder if the contents we described here, like the setup of the parameters, fits the scope.
Well, you're basically helping your information, helping the configuration of your testing with real world information. So that has some value. But I also saw that you're very worried about this information changing quickly, that it has to be up to date. So there needs to be a balance between, the information that we can sort of freeze for for many rounds of benchmarking, and the kind of information that just gets us started here from the regulators. Do you take my point?
Yeah, I see. And I think just as you said that these things are changing continuously. Maybe our work to focus on to find some really representative parameters should help, right?
Yes. Yeah. So
Okay.
so that's
Thank you.
the work then to find the representative configurations, parameters.
Okay, I see. And okay, and we really look forward to meet in person next time. Okay.
Yeah, for
Okay, thank you.
for San Francisco. Thank you.
Yeah.
Okay. So we've got one last talk here, and that is, hang on. Oh, shoot. The multiple loss ratio search material here. And Vratko, are you ready to go?
Yes, I am.
Okay. I'll give you, I'll pass control of the slides to you if you want to take it.
How do I take it? Ah,
It should
no,
be in your,
yeah. Okay, so how much time do I have?
let's try to keep this to 10 minutes or so, I think. I think everybody's getting tired and we're losing the audience.
Okay, so I will have to jump around. Okay,
Yeah,
so this is
that's why I
the
gave you
most.
control.
Yeah, thank you. So this is the most important slide when it comes to information about where the work is. So the big news is that in the previous meeting I mentioned one missing feature we would like to add, and the good news is that we have added this feature. I will talk about it later. Turns out adding this feature required some non-trivial changes. So it means that the current draft version published, MRSearch 03, is already outdated. And we will be working on creating 04, which properly describes what does the new feature do and what is the overall logic of the algorithm, because we have changed the whole logic. So this presentation will be the first description of the new logic, and the whole presentation is quite long and dense, so that it contains everything needed to understand what the new code is doing, and it is not realistic for me to cover it in 10 minutes. So I will skip ahead. What was the number? Okay, this is the number. So this is one of the slides I think will fit into 10 minutes. So now there is a word target, which is used to encompass 5 or sometimes 4 values. Usually the most important value is the loss ratio. This is why MLR search is multiple loss ratio search. So we know that in RFC 2544 we are searching for throughput, and this throughput looks only for trial results and ask, does this trial result has 0 loss or not? By introducing this loss ratio, users can specify, okay, I do not really need exactly 0 loss. I can tolerate some small fraction of frames being lost on SUT and still consider it like good enough. So this is one of the parameters that will be used in the search. Now the new thing is that we have 2 different durations. One is duration for a single trial, here called main trial duration, because yeah, so I needed some word to distinguish from other trial durations. And the other one is minimal duration sum. So this highlights the possibility that at the same offered load, we can have more than one trial. And it means one trial will be done, for example, at this main trial duration, but this one trial will be not enough for the algorithm to decide, okay, is this load too high or too low for the throughput I'm searching for. So this minimal duration sum is the time that has to be spent investigating a particular offered load before it can be classified as, is it too high or too low? And having these two parameters, it finally enables MLR search to do things that are done in binary search with a loss verification, which means you can have, for example, two trials. One of them has small loss, the other one has high loss, but the user specifies that the high loss is probably just a coincidence, some rare occurrence, and we are not interested in that. We are interested in the other trial that proves that SUT is sometimes capable to forward enough at this offered load. And yeah, so when there is space in the time for multiple trials, there is this parameter called exceed ratio, and this is where the user can specify what proportion of the time has to be good, meaning loss smaller than the loss ratio, and what proportion of the time can consist of bad trials, but as long as the proportion is low enough, this particular offered load is still considered. So in the next slide, I'll call it upper bound or lower bound. So in this case, lower bound is good. That means that the loss is not very high, and the binary search can continue investigating high loads. Upper bound is bad, meaning that the loss or this exit ratio is too high, and the search should focus on smaller loads. And as before, there is width parameter, which is used to determine when the search can stop. When there is upper bound and lower bound and they are close enough, the search can stop pay attention to this target. Okay. Yeah, I think I can jump ahead here. For people to more easily imagine how these parameters come to play, I have prepared a few examples. They are on the table on the next slide, but before I jump to the next slide, I need to talk about some of the abbreviations and context used on that slide. So the upcoming table has multiple rows, and what is common is that each row represents a situation for only one offered load. The value of that offered load doesn't matter, but there are multiple trial results available, and the load classification has to decide, okay, now that we see this set of results, does it mean that this load is upper bound or lower bound, or maybe we need more trials so that we can decide, because we have this duration sum, and the trial results so far are not enough to decide whether it will end up being upper bound or lower bound. So this So the common target for each row in the next table uses loss ratio 0 because that's the easiest to imagine. Main trial duration is 10 seconds, and among the trial results, there will be also results coming from 1 second trials. This is the feature of MLR search. It starts with trials shorter than necessary because it saves time, and based on the results of the shorter trials, when it comes to start measuring at longer trials, the algorithm has a good estimate of where the interesting loads will be, and time is saved. I use 10 seconds because that's a nice round number. Similarly, for the duration sum, I'm using 100 seconds. It means that for the classification upper bound and lower bound, we will need several 10-second trials, and the table will show the possibilities. For the exceed ratio, I have chosen 0.3, which means that up to 30% of the total seconds, when you sum the durations of all the trials, up to the 30% can come from bad trials, which means there was some frame lost, at least one, and it means that the other 70% have to consist of zero loss trials. If there is less than 70% of zero loss trials, then the load will be considered as an upper bound. The classification result depends on 4 values, and the abbreviations are GS, BS, GL, BL. G and B is good or bad. This simply means whether this trial had zero loss or not. S and L stands for shorter and longer. In these examples, longer means it comes for 10-second trial. Shorter means that it comes from 1 second trial. And yeah, I think I can jump to the table. So this is the important table because it shows corner cases, and there is also this explanation column which hints on the intuition behind them. And this is where I will spending the rest of my time. So the row number 1 is the good case. We do not have any short trials. We have long trials, 7 of them. Each of them is good, so zero loss. And that means even in the worst case, when the rest of the 30 seconds to achieve 100-second limit, if all the remaining 30 seconds are bad, still the exit ratio will be 7-3, which means 30% is bad. And if it is exactly the same, it is considered good enough. So that means the classification is lower bound. This is the good case. The row number 2 only has 6 trials of 10 seconds, which means in the worst case, if all the remaining 40 seconds are bad, this will be an upper bound, but we do not know. We need to continue measuring at this load, which means the classification of this load is unknown. Okay, row number 3 is the other side. In this case, all the trials that are available are bad, but there are only 3 of them, which means 30 seconds. So in the best case, all the remaining 70 seconds may end up being good. So we cannot classify this load yet. We need more measurements. That's why, in this case, the classification is still unknown. And row number 4 shows, for example, the same search. We do the 4th 10-second measurement, which ends up being also bad. And now it is clear the load is upper bound because there are only 60 seconds remaining, and even if they are all good, the exit ratio will be exceeded. So we can stop measuring at this load, and the MLR search will continue focusing on some smaller loads. The row number 5 is the first interesting one. We have 3 10-second trials, which all end up bad, and we have one 1-second trial, which also ended up bad. In this case, the logic says it is also an upper bound, because this one short trial, even if it is only 1 second, not 10 seconds, so 1 second is not reliable. But if there was packet loss already in the first 1 second, it means that if we did not stop the traffic after 1 second and continue for the 10 seconds, there will be at least one packet loss also in that case. You cannot unloose packets in this way. This means that this 1 second does count as bad second, and so the remaining number of seconds is only 79, which is less than 70. So we do not need to do another 10-second measurement, not even 1 second measurement. We can already classify this as an upper bound. And when you compare lines 4 and 5, you see we have saved 9 seconds just because we have reused a short trial result that happens to be there. This is the new feature. Well, one of the new features. Okay, what about good and short results? Row number 6 shows the best example. We have 60 seconds coming from good long and 10 seconds coming from 10 1-second short measurements. But in this case, we still cannot decide because from the fact that 1 second measurement had 0 loss, we cannot be sure that if we prolong one measurement from 1 second to 10 seconds, there will still be 0 loss. For example, we may be using some DUT that has large buffers, and 1 second is not enough to fill the buffers. There is a reason why users specified 10 seconds as their main trial duration, and 1 second is simply too short. It is not reliable, so even if it looks like 70 seconds of good results, it is not really 70 seconds of reliably good results. It is only 60 seconds of reliably good results, so it is still unknown, similarly to the row 2. This shows the difference, the asymmetry between good short and bad short results. Bad short results frequently count because you cannot unloose packets, but good short results frequently do not count because when you prolong the measurement, you can still have later lost packets. And the most complicated examples are 7 and 8. In line 7, we have a situation that looks almost bad. There are 30 seconds of bad trial results coming from long trials, but we have 7 and 3 coming from short trials. In this case, the intuition says that 7 to 3 on the short trials is what we expect to happen in, well, if there are no issues with buffers and similar. And this would be what we expect. So in this case, we cannot be too unfair. When there were only bad short results, we were counting them as real losses. But here we have 3 measurements, 3 1-second measurements with some loss, but 7 without some loss. We cannot say those 3 bad measurements will inevitably happen, so we cannot count them towards the 100-second limit. In this case, we say that the good and bad short trials cancel each other and do not give us any new information. So the only reliable information we have left is only 30 seconds of bad long trials. And in this case, it is the same as the row number 3. We cannot classify this load yet. And in the row number 8, we have added one additional short bad trial result. And as this is skewing the bad short against the good short, in this case, the algorithm counts it basically the same as the row number 5. There is some excess of bad short results, and we count that excess towards the total of 100 seconds. And in this case, the algorithm will decide that the load in question is an upper bound. So this is quite complicated, but if nobody sees any errors, this is where the additional time savings will come from. And there are 2 comments for the classification of lower bound. There are no shortcuts. You need good long results. But for the upper bound, there can be shortcuts. Short bad trials can save you time, but only in the case where there are not good short trials to cancel the bad short trials.
Right. Okay. Well, Ratko, I think that's a good summary of how there's complicated logic here, and you're having to deal with a lot of different conditions in classifying the results of each set of trials under each individual load. So, I think that's probably a good summary of where you are and where you're going with the text. Any questions about this material? We're running up to the end of our session now. I gave you a lot more than 10 minutes. So thanks for this update and summary, Ratko. Appreciate it. We're looking forward to the next version of text we can read.
Yes, thank you.
Okay. All right. Well, thanks everybody for participating. I'm really looking for more participation in terms of readership and review next time. I'll do what I can on the list to try to shake that out and get more activity going here for the benefit of the authors. Of course, the authors can help each other, and I've seen some of that happening, and that's good. So try to keep that up, guys, and we'll hopefully see you in San Francisco. Thanks again, everybody.